Hello everyone, Namaste and welcome to the hands-on learning session for IBM Flashsystem Storage. Today in this video we are talking about managing the external storage resources connected behind IBM Flashsystem Storage via fiber channel and logically via SAN zoning using the physical WWPNs. We are gonna use the IBM Legacy Fast Disk Storage System DS3500, the DS Storage Manager as a backend storage to the flash system with single IO group that has 2 node canisters. We will complete 3 main tasks. First, explore and manage the external storage systems. Second, use the IBM DS Storage Manager to verify the LUNs that are presented to the IBM Flash System or V9000 system. Third, we will create storage pools in the IBM Flash System using the MDisk that are coming from the external storage system LUNs. If this sounds interesting, then this session is for you. I will go step by step explaining what we do and what we observe at each point. You can pause the video to refer a specific information if you need. Let's begin by exploring the DS3500 storage subsystem configuration using the DS Storage Manager application. These resources are presented to the Flash System V9000. We are using admin server as a jump server to access all these resources for this lab. We will first access the DS Storage Manager client, which is installed on the Windows admin server. There is an icon for the DS Storage Manager. From the admin server desktop, double-click the DS Storage Manager icon, click the Device tab, then double-click the Storage System device to launch its management interface. The name may differ depending upon if someone has already renamed the storage system. A login prompt appears. Enter the administrator password as per the datasheet. Once authenticated, click View Storage System Profile under the Monitor tab. Go to the Controllers tab under Hardware, inspect the configuration, and note that the system has dual controllers. To check the specific device information, use the Find field and search for product ID using the binoculars icon. You will notice the product model is Fast Storage. This allows us to identify the product model, then search for worldwide node to view the fiber channel host interface card speed. At this point, it is important to note that the worldwide node name and the worldwide port names, both of which are unique identifiers used in the SAN environments. The first 2 and 6 bytes help identify if the device is Emulex, IBM or QLogic. And the last 3 bytes of the WWPN will help identify which system the ports belong to. We will soon come to use this in the lab. Next, switch to the Storage Array tab to observe how many arrays are defined on this DS3000 system. After making a note of this, close the profile window. Now let's verify the LUN presented to the Flash System V9000. From the DS Storage Manager, go to the Host Mapping tab. Under the default group, confirm the V9000 is defined as a host group name V9KA set and there is a host V9KA. Right-click the host and view its property to ensure that the host type is set to IBM TS SAN VCE. This is important for proper SCSI LUN ownership. Take a look at the list of logical volumes assigned to this host group. In the Defined Mappings window, review the volume names, LUN numbers and capacities. We have segregated the capacity to indicate which team on the drive. For example, 101 GB or 51 GB indicates team 1, 103 GB and 53 GB is R drive, 104 GB, 54 GB is for another team, 52 GB and 102 GB are for team 2. Also click the host group V9K set to identify the logical drives associated with the team set ID. Once verified, switch to Flash System V9000 GUI. Under Pools, select External Storage, check the external controller. Controller 0 is usually the default name for the first controller. We have renamed it already. Next, scroll to the WWNN section and confirm the last 3 bytes match to the previously noted DS3K system. (923A). They matches to the controller in the flash system. This is how we validate using WWNN. Now, switching back to IBM Flash System, scroll back to the left and rename the controller. Right-click and selecting the rename option. Observe the background command. Click close. Once the command completes, now expand the controller entry by clicking the arrow next to it and check the list of discovered MDisks. We can initiate a manual discovery by right-clicking the DS3K controller and selecting the Discover Storage option if no MDisk appears automatically, or by using the action menu as well. We have MDisk listed here. Check the access mode, capacity and LUN number for each MDisk. All newly discovered MDisk will show as unmanaged by default. Unmanaged simply means these MDisk are currently not being managed by IBM Flashsystem. Again, switch to DS3K backend storage to verify the number of provisioned LUNs to IBM Flashsystem. ID column can be used to sort the MDisk numerically to identify the controller ID easily. If ID column or any other needed column is not there, then right-click the column header to enable the required column in IBM Flashsystem. As mentioned earlier, I'm gonna use 53 GB and 103 GB disk, so identify those MDisk for these respective LUNs by their capacity. Select the 103 GB disks, right-click and choose Rename. Again, observe the triggered command. Each rename initiated a separate MDisk chmdisk command in the background. Repeat the same steps for the remaining 3 MDisk of size around 50 plus GB, which is 53 GB for our team, using the same naming convention and setting the starting index to 4 this time. Don't get confused with these numbers or the names. These naming convention matches to our lab requirement. The name in your production environment should match to the naming convention policies of your organization. Once renamed, verify that all 6 MDisk are correctly labeled. For example, I missed to add 103 in the previous rename task, so let's fix this. All 6 MDisk are correctly labeled now. Let's view the properties for one of our MDisk. Click View More Details. Here I can confirm the storage subsystem name, tier, UID of the MDisk, which is essential for correlating with the original source array or storage system. The tier shows enterprise disk. Scroll down, you will notice the path count, which should be 2 in most cases. This indicates how many active IO paths the MDisk currently uses. If the current path is less than the maximum path count, it may mean that one or more paths are offline. Let's customize the view. Now let's move on to creating storage pool using external LUNs presented to the flash system as MDisk. Go to Pools, select MDisk by Pools, expand the unassigned MDisk entry to check which MDisk are unassigned. This also shows the number of external LUNs that are available to be pooled. Now click Create Pool to define first storage pool. We are gonna create one pool for SAS and another pool for SATA. Confirm the extent size and then check the encryption box if it is not already enabled. For FS9500, the default extent size is 4 GB. It's worth noting that encryption is supported even for externally virtualized storage. Access the audit logs and notice all executed commands are being logged here. Again, let's go to Pools, MDisk by Pools, and create another pool for SATA. We will repeat the same procedure, accepting all default values. Again, observe the background command. Click Close. After both pools are created, verify the SAS and SATA pools. Pool is a container and these are empty pools. So now let's assign the MDisk to each of these pools. Expand the unassigned MDisk view again. Select the 3 MDisk with a capacity size around 100 plus GB. We can use an action menu to perform this task, or we can do a right click, select Assign, select the pool, select the SAS pool in the open dialog box, select Enterprise Disk as the tier technology, leave the encryption box unchecked since encryption is already managed. The system runs 2 background commands, the change MDisk command and the add MDisk command. Observe them. Click close. Now again go back to unassigned MDisk and multi-select the 50 plus GB MDisk to add them to the SATA pool. This time let's use the action menu and select the nearline disk as the tier. Click apply. Again observe the svc task command that changes the tier to tier_nearline and the add MDisk command. Click close. At this point check the total capacity of the pool. It matches to the sum of the capacity of each MDisk added to the pool. And this wraps up the entire workflow of managing external storage using IBM Flashsystem V9000. This is all for the day. I hope this walkthrough gives you a solid understanding of the full provisioning and validation process. Please do like, subscribe and comment for more such informational videos. We will discuss more about the CLI and other parts of the IBM Flashsystem in upcoming videos. Till then, take care.